Welcome to the Archaeoastronomy Database. Each month, the moon swings back and forth between a maximum northerly and southerly position. And over an 18.6-year cycle, the maximum position shifts from being less than what the sun reaches at the solstices at a minor lunar standstill, all the way to a position well beyond the solar range during a major lunar standstill. And right now, we are entering the point in the cycle where the moon is reaching those maximum positions each month towards the north and the south. So the Archaeoastronomy Database has put together information to share these dates and to maximize observation opportunities. This information is available on the Archaeoastronomy Database website with this link to a Google spreadsheet. The Google spreadsheet can be viewed on the web by anyone, and you can see that on the left there's a chart showing the standstill positions each month with a little lead up through the latter half of 2023 and now into 2024. The graph shows the positions of the moon at its maximums to the north, on the right side of the graph, and towards the south, a couple weeks later, on the left side of the graph. And each phase where these extremes are occurring appear next to the bars with the dates here at the right. And so you can see that there is a peak in the cycle in March of 2025, and there's slight fluctuations to the north or south over the course of the cycle. But this graph is showing maximums that are within a fraction of a degree of each other. So even these dips in the graph are still very close to the extreme position. You'll notice that each year, the phase at which the moon reaches these maximum positions works backwards from a waning phase to a more full waning phase to the waning half moon, and then on through gibbous, and then towards full for the northerly extreme, and the same pattern is repeating opposite for the most southerly extreme, with the full moons occurring near the solstices. And so the most northerly full moon occurs near winter solstice, and the most southerly full moon will occur closer to summer solstice. Now the moon can rise or set at any time of day or night, and as it cycles through these different visible phases at the extremes, some of those phases are more or less observable when the moon is rising or setting. So to do an observation, first thing is to determine if you're looking at a northerly maximum of the moon or southerly maximum, and then whether you want to observe the moon rising or setting, and then finding an appropriate phase for that viewing. So although this chart covers over 2 years of monthly maximums, and that's about 80 events, half of those are to the north and half of those are to the south. So that reduces that to about 40 events each. And then depending on if it's going to be a rise or a set observation, that reduces that further to maybe 20 that would be visible either rising or setting. And then there's only further reduction with more ideal phases and with weather conditions that might obscure observing a rise or a set. And if you want to observe at multiple sites while the standstill is ongoing, then there are fewer and fewer opportunities. In some ways, observing the moon at a standstill position under ideal conditions can be more rare than even observing a solar eclipse, as those occur in limited locations but at a regular interval of once or twice a year, depending on the ideal conditions. And the lunar standstill observations can be done multiple times over the course of these years, but then not again for 18 years. So every opportunity should be taken. The absolute maximums occur near the equinoxes in March and September, but the most ideal phases in many ways are near full, as mentioned before, around the solstices. The full phases have the advantage of rising and setting near sunrise and sunset, so not at extremely late or early hours, and also have the possibility of a little bit more light in the sky so that features of a site and also distant horizon features are more visible, even though the moon will still probably be glowing fairly brightly under the right conditions as the sky is dimming towards dusk or is still fairly dim at dawn. In other conditions, it might be necessary to use artificial lighting to highlight features of a site, and more distant horizon features might just be lost in the darkness of the sky, because even though the moon's at an extreme position, if you're trying to demonstrate an alignment and you can't see any horizon or site features, depending on what type of alignment you're looking at, then you've just got a photo of a bright moon with no reference points. So that's why those phases near full are often more ideal than any others. So you can see that this spreadsheet runs through the entire graph, and there's information and links that are of use, and then more information off here to the right, including the UTC time when the moon reaches this absolute maximum. But remember, that's not the time that the moon might be visible for any given location on the Earth. The declination value is also listed here, negative to the south, positive to the north, and then it mentions whether the moon phase is waxing or waning, new or full, and there's a rough indicator here of whether this would be ideal for viewing in rising or setting alignments. These are very general notations that work for most latitudes, but extreme latitudes it might be a little bit different. So you can see that, for instance, this waning crescent moon rises before sunrise, and so it might be well visible in those conditions, but it sets before sunset, and since it's such a thin crescent, it'd be very difficult to see under most conditions. Of course, a full moon rises around sunset, sets around sunrise, and is opposite the sun in the sky, and so it could be seen both rising and setting fairly easily. If we scroll over to the right, there is some information here that can be used to narrow down a specific observation event. And there are some settings here, and you can actually enter a location of your choosing. However, if you're just viewing the web page that shows the spreadsheet, you're unable to make any changes. So if you want to try some of these features, you'll need to click File and make a copy. And you can call it what you want. Click to make your copy, and then you'll be able to edit. And the Archaeoastronomy Database maintains a list of many sites that would be useful for observation. But as always, if you are undertaking observations at actual ancient sites, please observe all precautions for safety in accessing the sites and obtaining the correct permissions, and treat the sites with the utmost respect when visiting. So coming over here to the right, you're then able to select in this drop-down from any of the observation events that are listed here in the spreadsheet. And there's also links that can help you to figure out for a specific site what the offset from UTC time is. So you can enter your latitude and longitude in this box, and your UTC offset either as a negative number, being after UTC, or a positive number in hours before UTC. So right now the default is just 0. If there are daylight savings in effect, that number can shift by usually about 1 hour. So there are links over here that can help figure out some of these different offsets as well. You can also determine whether you're looking at a rise or set event by selecting here. And remember, right here it's just building the time and date, but this is the UTC time of maximum, not the rise or set time. That's what you're going to have to determine, and these links to the right are intended to help with that. So once you have the information in, your latitude and longitude and your UTC offset, these links on the right will then be generated. By clicking on them, you'll see that your location is automatically entered in. And you're in the month that you selected, and you may have to double check that you're looking at December 15th. So you can scroll down and find that date in the month. And you can see here that the moon is rising and setting in the table. The table actually has moonrise and moonset in 3 different columns, because on some days the moon rises before it sets, and then as it shifts, there are other times of the month where it will be setting before rising within a 24-hour period. So you can come down and find the date and get an idea of when the moon will be rising or setting. Now, not only can you get a rough indication of the rise or set time using this site, but you can also use it to determine the best date for observation. Depending on your location, the dates listed in the spreadsheet may vary by 1 day previous or following, or there are even instances where for 2 days the moon is rising at almost the exact same maximum position. So if you're back on the spreadsheet, you can see this link to a help page on the Archaeoastronomy Database website, which will give you some more information on how to do this using the time and date website. So there's information that you can read through here, and another link to the spreadsheet, as well as another link to timeanddate.com. And you can see here a screenshot of a table like the one we were just looking at with some notation. First, I want to point out this chart below. And you can see here is a compass of azimuths showing a sample northern maximum rise azimuth for the moon and its corresponding maximum northerly setting azimuth, and then the maximum southern rising azimuth and the maximum southern setting azimuth. So for the rising azimuths, you'll see that each month the moon will be rising at an azimuth that will range between the minimum azimuth towards the north and the maximum azimuth towards the south. And so for any given date, the moon will either be increasing in azimuth until it stops and turns back and decreases in azimuth to a minimum, and then stops and turns again. The same is true for setting azimuths. Wherever it begins to set on a given day, it will be working in one direction or the other until it reaches a maximum azimuth, the highest value that will appear as an azimuth for that month. And then it will turn and work its way back to the minimum azimuth that will appear for that month. So you can match these annotations on this azimuth chart on the time and date website by looking at the azimuth values given either in a moonset or a moonrise column and watching those azimuths climb or decrease. So here we can see it's at 307, climbing to 317 to 324, and then it hits 327. You can see these little arrow indicators also reach a maximum before turning again. And so after this maximum of 327, the setting azimuth reduces again to 326. But as you can see, it's only 1 degree difference the following day, and then drops several degrees the day after that. The same is true here for the rising azimuth, reaching a minimum value. So starting high, 60, 50, 41, 35, and then bottoming out at 32, and then increasing again to 35 and 40 and 48 and so on. So around halfway between these maximums, the moon will be rising and setting somewhere near east and west. And then again, we can see that the azimuths are decreasing to a minimum azimuth for the setting position toward the south, and increasing towards a maximum azimuth for the rising position. So the southern standstill, you're looking for the minimum azimuth for the month for setting and the maximum azimuth for rising. And for the northern standstill, You look for the maximum azimuth for setting observations and the minimum azimuth for rising. And in reality, any observation close to the maximum, so for example, even this 32 or these two 35s, would still be useful for an observation if, for instance, weather or other circumstances didn't allow for observation on the ideal date. A photograph that has reference points for features within a site or on the horizon that shows the disk of the moon clearly can be used to calculate the actual position for any site, so those observations are still very useful. And in fact, the maximum positions attainable even today are not quite as extreme as in the past. So any observation that has the moon disk close to the maximum positions can be used to extrapolate the more precise position of the moon for any given site in any time period. Now if we go back to the spreadsheet, we can look at another link. The dates and times given on timeanddate.com are calculated for no elevation on a horizon. But remember that if an observation is planned for the moon rising or setting with any sort of elevated horizon, then the moon will rise later than generally listed times and will set earlier. In the case of rising, if you're in position at the times listed on timeanddate.com, you would be very early and you'd have to wait a little bit longer, which in most circumstances you want to arrive early anyway. However, for a setting moon with an elevated horizon, if you were to arrive even with a little bit of extra time for the listed setting times, you might completely miss the event, especially if it's a fairly elevated horizon, as the moon will be setting considerably earlier than the listed times, depending on the location. Now if we go back to the spreadsheet, this next link is to a website called peakfinder.org. And if you've entered your latitude and longitude and especially selected rise or set, this link will automatically be generated for your location and will be pointing towards the rise or set position of the moon. This website takes a moment to load, but if you wait, it will eventually load a 3D rendering of the terrain from your given location. And if you wait a moment more, that resolution will increase, and eventually the rising and setting position of the sun and moon will be plotted against the horizon. There it's appearing. And you can see for our location, we've got this blue line, and that represents the moon, and there will be a time listed here. So we've got 1507 for moonrise. If we go back to time and date for our position, you can see that the moonrise is at 3 p.m., 3:03 p.m. And so if we change that into 24-hour time, that is 15:03. And so the difference here is a matter of minutes. And you can see this is a fairly low horizon. And so not too big of a difference there. But if we were to be looking at a site with a slightly more elevated horizon, let me put in some sample coordinates. And then we were to generate this link. And as we wait for this to load, we'll see that this sample site has a much more elevated horizon than the previous site. I'm giving it one more moment to load in the moon rise position. All right, so we can see that the moon is rising here. And if we select this menu and then switch to the clock, we can drag this bar towards the listed time, and we can see that this site has a double rise, with the moon rising around 3:12 p.m. and then appearing again around 3:30. You can also click here to change the time in minute increments. And you can also shift the date by one. I wanted to show this example that the moon will be listed now on December 14th, rising above this high elevation, and the time listed is specific to when it intersects with that horizon elevation. So this website can be very useful in giving that rise and set position as with a more specific time instead of just the general time listed for a flat horizon. You can also use this website to double check the ideal rise and set date by just shifting and seeing how the moon moves between one day and the next. If we go back to our previous example, you can see that on the 16th, it's fairly close to this position, but the 14th in a different position. So if you wanted some flexibility in this date, the 15th would be ideal. The 16th would not be too far away, but by the 17th, it's moved quite a bit, and a day early on the 14th. Also quite distant from the ideal position. Now with Peakfinder, if you're interested in exactly how the disk of the moon intersects the horizon, you want to be zoomed in as much as possible because it doesn't scale the moon at further zoom levels. So when you're zoomed out like this, you can see that the moon's not really getting as small as it should in proportion to this horizon feature. See now from this position, the moon's disk is so large it looks like it never actually disappears from view. But if you stay about as zoomed in as you can get and still see the features that you're interested in, it shows a very different story, with the moon rising, going behind the horizon, and then coming back up again. So that is one thing to keep in mind. The ideal way to double check these things is to use Stellarium with an imported horizon, because the moon is always going to be scaling correctly in Stellarium. And so in the future I'll do another video showing how to bring in an imported horizon for Stellarium. Returning to our spreadsheet, there's one further link that is generated. This is on a website called mooncalc.org. So for this last link, we will change to a set event. And we are looking at the same standstill event on December 15th, 2024, with the full moon towards a maximum northerly position. So the selected event is summarized here, and with the coordinates of a selected site input, we can follow this link, and we will have a view of the site with imagery, if available. And you can see information listed here to the side with moonrise and moonset. Again, these rise and set times are generated assuming no elevated horizon. But what this site can do is plot out the azimuth position of the moon over the course of the day. And for our set position, it actually set and then rose later in the day. So you can see as the moon is coming in, it will be setting at this position, and in this case it's aligned with the entrances of the henge. We zoom out a little bit and keep our camera position the same. You can see that azimuth coming through. And again, it's possible just to double check by selecting the previous day. You can see that that azimuth is less ideal, and by choosing the following day, you can see that the azimuth is not quite as centered as before, but is closer than the day previous, so might still be a viable option. We're getting a close observation. And of course, even with the ideal modern date, the moon would have probably been slightly further in this extreme north direction when the tilt of the Earth was more extreme, as it was in the past. So hopefully this gives you some tools to use in determining observation dates, and especially determining the rise and set time, and for sites with any elevated horizon, Peakfinder will be very useful to you in that way. So please comment on the video if you have questions, or follow some of these links to a discussion on Facebook and to the website, which has more useful information. And it takes a lot of time to put together this information and share it and offer this support. So if you're at all able, please consider donating on Patreon or PayPal in order to support this work. Thank you for your interest in the Archaeoastronomy Database, and I hope you enjoyed this video.